Good morning, all. Am I audible? Good morning, everyone. Am I audible? Good morning. Good morning, everyone. Today, we will be discussing about electric vehicle design. This is an exciting topic that gaining a more and more attention as we move towards to a more sustainable future. Am I audible? Yeah. So let's get started. Shall we start the class now? Savitri, Rani. Yeah. So, as you may already know, our Pantech e-learning. Good morning, Rani. Good morning. So, at Pantech e-learning, we have spent 20 years mastering our field. Now, we are sharing that expertise to the edutech platforms to help you succeed in your learning journey. So, recently we celebrated our 20th anniversary, decades of excellence in our tech education. So, now we are excited to share our experience and knowledge with you. So the main vision of a Pantech e-learning is to help 10 million students easily learn the technology. So in this live session, we are here to turn our vision into reality. So first, today we are going to talk about the EV trends and EV technology and EV charging. So in this EV charging, what kind of charging infrastructure will be available in the market and battery technology, what different types of battery that are used in electric vehicles. So we are going to see these topics today. So first, what is global and regional trends in the electric vehicle industry? So that means this global and regional trends in electric vehicle industry they provide insights to the adoption of growth of electric vehicles over the worldwide in some specific areas. So this global EV trends that refer to all over the patterns that developments in the electrical vehicle market around the world. So these trends show how electrical vehicles are becoming more popular and more important in this transportation industry. So these trends are driven by the factors like government policies and to reduce the pollution and the combat with the climate change and improvements in the battery technology and development of charging infrastructure. So first we will see our 2021 EV stock project, EV stock market. So in 2021, more people around the world started using the electric cars and other vehicles. Good morning, Jagannathan. Good morning, all. So in 2021, more people around the world started using these electric cars and other vehicles. So first, the passenger cars. So about 16.7 million electric cars were sold in the 2021. So they made up of 90% of all car sales. So people like electric cars because they are efficient and don't harm the environment. So next one is the commercial vehicles. So what are the commercial vehicles? So vans and trucks. So they were 180. That means 1,80,000 electric vehicle delivery vans and trucks sold in that year 2021. So which is 1% of the total global sales. So here the businesses are using some electric vans and trucks because they save money, are better for the environment. So next is the electric buses. So in 2021, 685,000. These electric buses were sold in that year 2021. So they made up 44% of all bus sales. So more cities are using these electric buses to have cleaner and quieter public transportation purposes. So next one is the two-wheelers and three-wheelers. So we know electric scooters and electric bikes. Many people bought 275 million electric scooters and bikes, making that up to 42% of the global sales in this category. So here, next we will see 2040. So 2040 EV stock projections. So by the year 2040, we think there will be about 727 million electric cars sold. So which would be 75 of the global car sales. So the people all over the world will choose the electric car because they are getting a better and cheaper way. So commercial vehicle in the sense, electric delivery vans and trucks will also be more common. So with 15.5 million, that means 54% of the global market. So the businesses will use these electric vans and trucks to save money and help the environment. So next is the electric buses. So here the number of electric buses will keep growing, that we can expect a 1.7 million to be sold by the year of 2040. So that means 83% of all bus sales, global sales. So cities will use different buses for the public transportation purposes. Next is the two-wheeler and three-wheeler. So even smaller electric vehicles will be very popular nowadays. So with a predicted value 758 million sold. That means 83% of the global sale worldwide. So these electric scooters and bikes are becoming a very common way to get around cities because they are convenient and they don't pollute the environment. So these trends shows that electric vehicles are becoming a most popular choice for the transportation purpose all around the world. So they are getting a better and eco-friendly, and people are choosing them to help the environments. So that's why here these electric car vehicle stock projections for 2040. By the Bloomberg book, I took these data from Bloomberg. Yeah. So next is the regional trends. So we know India has set some big targets for the year 2030 to promote their electric vehicles. So they want to achieve passenger cars. So these are all this blue line is a passenger EV passenger car, and this red line is a EV bus share. All the global market, EV commercial vehicles and EV two-wheeler vehicles. So these are all the shares. So passenger cars in the sense they aim to achieve 30% of the new passenger cars sold in India be electric. So next one is the commercial vehicle. So what is the commercial vehicles? We know already. So they want 70% of new commercial vehicles like trucks and vans to be electric. So next is the two-wheeler electric vehicles. So these two-wheeler electric vehicles are around 80%. So like scooters, EV motorcycles like that. So these commitments are by the Japanese automakers. So some famous Japanese car companies have made promises about their electric vehicles by the year of 2030. So the Toyota EV, they plan for a 40% of all the cars they sell to be the electric. And the Nissan also, they want 50% of the car sales to come from electric cars and hybrids. So next one is we all know Honda. So Honda plans to make 30 different electric car models and produce 2 million units by the year of 2030. So these goals and commitments shows that both India and Japanese automakers are very serious about electric vehicles, and they want to play a big part in the future of clean and sustainable transportation. So these are all the global and regional trends related to electric vehicle. Next, we will see the types of electric vehicle. So what are the types of electric vehicles available in the market? Do you have any idea? What are the types of electric vehicles that are available in the market? Do you have any idea? Anyone? Leave your answer in the comment box. What types of electric vehicles that are available in the market? Anyone? Yeah, Pratik. Then hybrid EV. Good morning, Usharani. So I will tell you, first is the hybrid electric vehicle and next one is the plug-in hybrid electric vehicle and battery electric vehicle and fuel cell electric vehicle. So first we will see one by one. What is hybrid electric vehicles? So these are the electric vehicle types: hybrid electric vehicle and plug-in hybrid electric vehicle and battery electric vehicle and fuel cell. I will tell you. So first is the hybrid electric vehicle. So this hybrid electric vehicles combined with the internal combustion engine, that means typically gasoline. So that combines with the internal combustion engine ICE, that we can say like that, ICE, with an electric motor and a small battery. So these vehicles can run on both the gasoline engine and the electric motor, either separately or together depending on the driving conditions. So this hybrid electric vehicle are a noun for the improved fuel efficiency and also reduced emissions compared to the other gasoline power cars. So this is what hybrid electric vehicle. And next one is the plug-in hybrid electric vehicle. So this plug-in hybrid electric vehicle. So what is this plug-in hybrid electric vehicle? So the PHEVs. So this plug-in hybrid electric vehicles are similar to the hybrid electric vehicles only, but comes with the larger battery. So here you can see this is a battery, but comes with the larger battery that can be charged by plugging into an electrical outlet. So this plug-in hybrid electric vehicle can operate in the electric mode for a certain range before switching to the gasoline engine. So they offer the flexibility of running on electricity for a shorter trips, and they're using the gasoline for a longer journey. So resulting in a fuel consumption and emission. So this is what this plug-in hybrid electric vehicle. So here you can see this is a gearbox and this one is the electric motor and this one is the combustion engine and this is the battery. We know this is the fuel tank and this is the what is this electrical outlet. So next one is the battery electric vehicle. So what is this BEV? Battery electric vehicle. So these battery electric vehicles are entirely powered by electricity only. So that's this electricity stored in a larger battery pack. So this electricity stored in a larger battery pack, they do not have an internal combustion engine and also they produce a zero tailpipe emissions. So this battery electric vehicles needs to be charged through an electric outlet or some charging station. So and can provide the various ranges on a single charge depending on the battery size. So this is what battery electric vehicle. So this is a 100% electric motor. That means entirely powered by the electric motor only. So next one is the fuel cell electric vehicle. So what is this fuel cell electric vehicle? Here this fuel cell electric vehicles use hydrogen as a fuel source to generate the electricity through a chemical reaction in a fuel cell. So this electricity powers an electric motor that propels the vehicle. So with that, with the only byproduct being a water vapor. So here this fuel cell electric vehicle are known for their long range capabilities also and the fast refueling times and but they recover access to hydrogen and refueling infrastructure. So each type of electric vehicle drive, it offers its own advantages and considerations. So this hybrid electric vehicles offers the improved efficiency, and PHEVs, that means plug-in hybrid electric vehicle, provides the flexibility, and this BEV offers the zero emissions but the limited range. And fuel cell electric vehicles excel in long range applications with these zero emissions. So here the choice of an electric vehicle drive depends on a variety of factors such as the driving patterns and infrastructure availability and environmental goals. So these are all the types of electric vehicles that are available in the market today. So next one we will see vehicle categories. So what is a vehicle? What type of vehicle categories will be there? So here electric vehicles are available in the various categories. So first one is the passenger cars. So we know these electric passenger cars are designed for the personal transportation purposes. So example include electric sports cars and electric bicycle and electric scooter, like that. So next one is the commercial vehicle. So what is a commercial vehicle? So we know commercial vehicles are mainly used for the business purposes such as the transporting the goods and passengers. So they are known for their efficiency and lower operating costs. So here this commercial vehicles examples in the sense include the electric delivery vans and electric trucks and electric minibuses. So next one is the bus. So electric bus are mainly designed for the public transportation. So because they offer a quieter alternative to traditional diesel or a gasoline powered buses. So these examples include the electricity buses and electric long distance coaches, like that. So next one we know these two-wheelers and three-wheelers. So electric two-wheelers are a very smaller vehicle designed for the personal use. Examples include the electric motorcycles and electric scooters and electric e-bikes, like that. So electric three-wheelers in the sense we all know the rickshaws are commonly used for the short distance transportation in urban and rural areas. So there are these categories represents the diverse range of electric vehicles that are available in the market. So each category has its unique advantages and applications that contributing to the growth of sustainable and clean transportation options. So next is the fleet electrification. So what is a fleet electrification? Do you have any idea? What is a fleet electrification? Do you have any idea about this fleet electrification? Anyone? Give your answer in the comment box now. What is a fleet electrification? What is the fleet electrification? So fleet electrification is when a group of vehicles that used for things like taxis, delivery or buses switches from the regular gasoline or diesel vehicles to the electric ones. So this switch can save the money, can reduce the pollution and work the best when the vehicles follow some regular routes and schedules. So here, this fleet electrification refers to the process of transitioning a group or a collection of vehicles that is known as a fleet. Yeah, exactly. ICE to zero combustion engines. So from the traditional internal combustion engine vehicles to the electric vehicles. So this transition involves replacing or adding the electrical vehicles to the fleet for the various purposes such as the transportation or a delivery or other operational needs. So by using this fleet electrification can involve converting the existing ICE vehicles to electric power. So this is one of the primary motivations for the fleet electrification is the potential cost saving over the time. So these electric vehicles often have a lower operating and maintenance cost compared to the traditional gasoline or other diesel vehicles. Next is the environmental benefits. So this fleet electrification can help reduce the greenhouse gas emissions and air pollution. So because these electric vehicles produce the zero tailpipe emissions, we know, so that contributing to improve the air quality and reduce the carbon footprint, which aligns with the sustainability and environmental goals. So many governments or municipalities offer the incentives and subsidies to encourage the fleet electrification, such as the tax credits and grants and access to the special lanes or a parking. So successful fleet electrification requires the careful planning of a charging infrastructure, maintains the facilities and employees to ensure a smooth transition and efficient operation. So mainly this electric fleet electrification is a critical step towards reducing our emissions, improving the urban air quality and achieving the sustainability goals in the transportation sector. So next we will see job opportunities that are available in the electric vehicle industry. And so we know, according to the Ministry of Skill Development and Entrepreneurship, MSDE, so we all know this one. So many employment opportunities will be created in India's electric vehicle industry over the next decade by 2050. So here Niti Aayog. So Niti Aayog estimates that the EV sector will produce more than 2 million extra jobs. So here at present the average yearly income for an electrical design engineer. So what is the average yearly income from the electrical design engineer in India? 4.0 lakhs with the salaries ranging from 2 lakhs to 9.3 lakhs. So the government expects the EV industry to help the country's economic development also. Because this electric vehicle industry is gaining a popularity due to its positive environmental impact and the low operating expenses. So that's why electrical engineers have many job options in electric vehicle production side and design and research and maintenance expansion like that. So this the main income of a fresh electric engineer can reach up to the 8 lakhs per year or a 66,000 per month. So over the next 10 years, in India or other countries will be watching carefully to see how electric transportation evolves and grows in popularity. So these are all the companies. What are the companies? Tata Motors and Mercedes-Benz, Siemens, Tesla, Ola Electric, Mahindra Electric and Maruti Suzuki. So these are all the companies, all part of the electric vehicle industry. So if you are interested in electric vehicle, you can find a job related to the electric cars and technology in these companies. Roles might including the designing electric vehicles, making the electric vehicle components or selling or marketing electric cars and developing EV charging infrastructure. So here these companies like Tata, Benz and Tesla will create the variety of job opportunities in various roles. So they will need people for the manufacturing side and engineering and design and sales and marketing, customer support and more. So if you are interested in working for these companies, there are a diverse career options available for you to explore your knowledge related to the electric vehicle industry. So many companies, Tata Motors and Ola Electric, they have planned to put charging stations also at different cities throughout the India. So this electrical engineer will get the possibility to work in these charging stations. So in recent news, the Tata Group has taken a very significant step forward in the electric vehicle industry by announcing their plans to establish a Giga factory. So what is a Giga lithium factory? So Giga factory for a lithium ion cell batteries in Gujarat. So this initiative, it will align with the growing demand for the electric vehicles and sustainable energy solutions also. Additionally, our TN government, so Tamil Nadu government has shown a strong commitment to the electric vehicles sector. So they will create 1.5 lakh jobs in the industries over the next 5 years. So these developments highlight the expanding opportunities and importance of the EV sector that is present in the future market, job market. So these are all the job opportunities that are available in the electric vehicle industry. So next, we will see the EV charging. So EV charging station, so that means charging station for electric vehicles serve these several important purposes to ensure safe and efficient charging. So first, connecting the electric vehicles to the grid. So what is it? Charging stations or the main bridge. So that means charging stations is like a bridge between the electric vehicle and the electric grid. So they provide the interface for electric vehicles to draw the electrical energy from the grid for the charging purpose. So next one is the dedicated circuit prevents the overloading. So that means charging stations are typically installed with a dedicated electric circuit. That means the electricity used for the charging does not interfere with the electrical appliances in our home or a facility. So it helps to prevent overloading and also that ensures the consistent power supply for the charging. So next one is the safe connection before power can flow. So before any electrical power can flow into the electric vehicle, a secure and safe connection must be established between the charging station and the vehicle. So the main point this one. So this ensures the charging process is safe for both the vehicle and also the user. So next one is the preventing the electric vehicle battery damage. So charging stations nowadays are designed to communicate with the electric vehicle to provide the right amount of electric power at the correct voltage and current levels. So this prevents overcharging or undercharging, so which can damage the electric vehicle's battery. So mainly it helps to extend the battery's lifespan and also ensures efficient charging. So these charging stations plays a very critical role in safe and efficient charging for the electric vehicles. They protect the vehicle's battery and they protect the prevent any electrical overloads and ensures that the connection to the electrical grid also. So this making the charging process reliable and safe for the users. So this EV charging, the charging time for electric vehicle can vary depending on the several factors, including the electric vehicle's battery capacity and charger's power output and state of charge of the battery when you start your charging. So first, this is a home charging. So in this home charging, so there are two levels. So one is the level 1 charger and another one is the level 2 charger. So I will explain you. Level 1 charger. So what is this level 1 charger? So this is a residential charging. So this is a standard household outlet. So 120 volt in North America. So here I will tell you the residential charging. So when electric cars were becoming more popular, so the focus on allowing people to charge their cars at a home. So this means setting up a charge system at people's house. So charging at home is a common one. So around the world, about the half to 4/5. So that means all of charging of electric car happens at the people's homes. So this means most people can charge their electric cars where they live. So there are two types of chargers. One is the level 1 charger and the level 2 charger. So level 1 chargers are the slowest one. So they give you about the 3 to 8 kilometers of a driving range for every hour you charge. So how fast you can charge depends on your car. So some cars can't charge any faster with a level 1 charger because they are limited by the design. So this level 1 chargers use the regular household electricity like what you use for your light and appliances like that. So it's standard about a 120 volt. So in simple terms, these level 1 chargers are like a slow chargers that you can plug into the regular outlet at the home. So they are not much super fast, but they can still charge your car if you leave in a plugged in a overnight. So next one is the public charging. So before we see the level 1 charge, so now level 2 charge. So what is this level 2 charge? So these charges you can find in the public places like the shopping centers or parking areas like that. So they charge your electric car faster than the level 1 charge. So with the help of the level 2 charge, you get about 16 to 32 kilometers for driving range for every hour you charge. So just like with the level 1 charges, how fast your car charges with the level 2, that depends on your car's design. So here this level 2 chargers use the alternating current power. So they usually provide a 7.2 kilowatt hours of power at 240 volts. So we can find a level 2 chargers both in public places and for use at home also. So these level 2 chargers are very cheaper to install and also it operated compared with the DC fast supercharge. So these DC fast chargers are the super fast chargers. So you might see on highways or special charging stations like that. So this level 2 chargers, this level 2 chargers also is limited by how powerful your car owns charger. So some cars can take in a power faster than the others. So next one is the DC fast chargers. So these DC fast chargers are the super fast charging station for electric vehicles. So they can charge your electric vehicle car really quickly. So giving you about a 95 to 128 kilometers of a driving range for every hour you charge. And so unlike the level 1 and level 2 chargers that use the alternating current AC and here level 1 and level 2 chargers that use the alternating current, here DC fast charger use the DC current. So this type of charger is a more suitable for super fast charging. So this DC super fast chargers typically around 50 kilowatt of power but some can go up to the 350 kilowatt. So more power means faster charging. So these chargers are very costly to set up and also it run compared to the level 1 and level 2 chargers. So because these fast chargers are known for their speed only, so they can get your electric car charged up much more rapidly than the other two types of the chargers. So these are the chargers available in the electric vehicle industry. So next we will see what type of electric vehicles are used as a energy storage in electric vehicles. So what type of batteries that available that commonly used for electric vehicles. So first one is the lithium ion batteries and next one is the lead acid batteries and another one is the nickel metal hydride batteries and last we have a ultra capacitors. So let's see one by one. So what is lithium ion batteries? So we know lithium ion batteries nowadays a very popular one because it offers a very high energy to weight ratio. And this lithium ion batteries allowing them to store a lot of energy in a relatively small and lightweight package. So that is why this is a very popular. So because this is a crucial for electric vehicles. It provides a longer driving range without adding any excessive weight. So lithium-ion batteries can endure a larger number of charge and discharging cycles, so that making them suitable for the long lifespan expected from the electric vehicles. So they can be charged relatively quickly, which is convenient for the electric vehicles who want to recharge their electric vehicles in a reasonable amount of time. So that lithium-ion batteries have a low self-discharge rate. So that means they can hold their charge for extended periods and also reducing the need for a frequent recharging. So next advantage of this lithium-ion batteries is a compact size. So we know lithium-ion batteries have a compact design allowing for a flexible placement within the electric vehicle. Next one is the nickel cadmium batteries. So what is a nickel cadmium battery? So we know this nickel cadmium batteries are a noun for nickel metal hydride batteries are a noun for their durability and ability to withstand the extreme conditions. So that making them suitable for the certain applications within the electric vehicle. It has a wide temperature range. So what is that wide temperature range? They can operate effectively in a wide temperature range, that making them useful in a various climates. So this nickel metal hydride batteries have been used in electric vehicles for a long time. So next one is the lead acid batteries. So we know these lead acid batteries are relatively inexpensive that compared to the other battery technology. So that this lead acid batteries require the minimal maintenance and easy to handle also. So these lithium lead acid batteries are widely available, that making them accessible for a smaller electric vehicle markets. Next one is the super capacitors, that means ultra capacitors. So this capacitors are rapid charging and discharging. So ultra capacitors can store and release the energy easily and quickly, which is useful for the application where the rapid burst of power are needed. So such as a regenerative braking in electric vehicle, like that. So they have a longer cycle than many battery types, that making them suitable for high demand and high cycling applications. So and also it has a high efficiency. That means it offers the high charge and discharge efficiency and also reducing the energy loss during the power transfer. This ultra capacitors also over a wide temperature range and having a long service life, that contributing to the overall reliabilities of electric vehicles. So each of these battery technologies, battery types has its own set of advantages and disadvantages. So making them suitable for different types of electric vehicles and applications in the EV industry. So manufacturers only choose the best option based on factors like cost and performance and specific use cases. So let's see the battery swapping. So what is a battery swapping? So we know this battery swapping is a method for electric vehicles to quickly replace that used batteries with the fully charged ones. So in recent days, this battery swapping technology is a very boom. So it's like exchanging used batteries in your remote control with a fresh one. So here, this battery swapping is a very easier for the motorcycles and scooters, and because their batteries are very smaller and easier to handle compared to those in cars. So that's why it's also more cost effective to have the multiple batteries for these smaller cycles. So this battery swapping can be used for electric rickshaws as well. These vehicles often the multiple batteries, and swapping them is a very convenient way to keep them running. So this battery swapping can work well with the renewable energy sources also, like the solar and wind power, like that. So excess renewable energy can used to charge the spare batteries, and then these batteries can be swapped into the vehicles when it will need it. So these battery swapping can reduce the upfront cost of electric scooters and motorcycles, because you don't need to buy an expensive battery. Instead, you pay for the electricity and the battery service only. So it can also increase the lifespan of these vehicles, because the batteries can be replaced when they wear out. So rather than having to replace the entire vehicle. So some companies like this KYMCO and this Immota from the China. So they operate a larger networks for the battery swapping stations. So they provide this service to the users of their electric vehicles. So big companies Honda, KTM and Yamaha have joined together to create this battery swapping stations. So in simple terms, this battery swapping is a way for electric vehicles, especially the motors, scooters and rickshaws. So to quickly replace their batteries, because it's a very cost effective one, and it can work with the renewable energy sources also, and they can make these vehicles cheaper and also long lasting. So next we will see the some important parts of the electric vehicle. So EV parts. So what are the EV, what kind of the parts that are available in the electric vehicle? So we know battery is a very most important one. So because the battery is the most crucial component in electric vehicle, because it stores the energy that powers the electric motor and providing the vehicle with its propulsion. So EV batteries we know typically lithium ion batteries that made up of the individual cells grouped together in a module or a pack. So this battery capacity is measured in kilowatt hours and it determines the vehicle's driving range. So next one is the electric motor. So what is the electric motor purpose here? So we know the electric motor is a main power source for an electric vehicle, converting the electrical energy from the battery into the mechanical energy to drive the vehicles. So most of the electric vehicles use the electric motor called the permanent magnet synchronous motor. That means PMSM motor, which is a highly efficient that provides the instant torque also. So next one is the charging station. So the charging system here that is mainly used to recharge the electric vehicle batteries from the external power source, such as the charging station or a wall outlet like that. So we know already this one. So charging stations comes with the several different types, including the level 1 charger, level 2 charger and DC fast charger. So next one is the onboard charger. So what is the purpose of onboard charger here? So we know the onboard charger converts the AC power from the charging station. So AC power from the charging station to the DC power that can be stored in the battery. So the charger is typically built into the electric vehicle that is capable of accepting power from the different charging sources. So that's why we use the onboard charger here. So next one is the converter and inverter part. So we know the converter is used to convert the high voltage DC power from the battery to the lower voltage DC power needed to operate vehicle's electrical system, such as the light, air conditioning and some infotainment system like that. So next we will see the block diagram. So what is this is a simple block diagram in electric vehicle. So we know in an electric vehicle, the control signals from the various components plays a crucial role in the electric vehicle's operation. So first, the motor controller part. So here the motor controller receives the control signal from the vehicle's control system. So which includes the input of the accelerator pedal and brake pedal and other sensors such as the wheel speed sensor like that. So based on these signals, the motor controller adjusts the power supply to the electric motor to control its speed and torque and direction of rotation. So this electric motor converts the electrical energy from the battery pack into the mechanical energy to propel the vehicle. So here the motor receives the control signal from the motor controller part which determines the recovered speed and torque based on the driver's input and also the vehicle's operational condition. So next one is the battery. So this battery provides the electrical energy to power the electric motor. So here the BMS monitors the battery state of charge, state of temperature and other parameters and sends these control signals to the motor controller to adjust the power output and protect the battery from damage. So next one is the vehicle body. So what is the purpose of the vehicle body? So this vehicle body includes the various components. What are the components? It is a steering system, brakes and suspensions and wheels, and that affects the vehicle stability and also overall performance. So these control signals are from these components and then fed back to the vehicle's control system which adjusts the power output from the motor and regenerative brake system to maintain optimal vehicle dynamics and also the efficiency. So for example, if the vehicle is turning means the motor controller may reduce the power output to prevent the wheels from the slipping and maintain the traction. So overall, the control signals are from the motor controller part and motor, battery, vehicle body. So they all work together to ensure the efficient and safe operation of the electric vehicle. So let's see some of the forces. So vehicle basics, we will see some of the forces here. So this is the push force. We know this is the opposite of the push force. That means the friction force. And so here, so this is the forces that act on the vehicle. So first one is the rolling resistance force. So what is a rolling resistance force? So this rolling resistance force that opposes the motion of the vehicle's wheel as they roll on the ground. So this rolling resistance mainly caused by the deformation of the tires and interaction between the tires and the road surface. So here this rolling resistance force increases with the vehicle speed and also the tire pressure and decreases with the tire size and tread pattern. Next one is the aerodynamic force. So this force we know already. So this is a force that opposes the motion of a vehicle through the air. So this aerodynamic drag force is caused by the air's resistance that the vehicle encounters as it moves forward. So it increases the vehicle speed and the frontal area and decreases with the vehicle's shape. So these aerodynamic features such as the air dams and spoilers in the electric vehicle. So next one is the hill climbing force. So this is a force when it requires means to overcome the effects of gravity when a vehicle is climbing a hill. So hill climbing forces increases with the steepness of the grade and also the weight of the vehicle. So next one is the acceleration force. So what are the acceleration forces? So this is a force mainly it's required to accelerate a vehicle from the standstill position or to increase its speed. So this acceleration we know that is directly proportional to the vehicle's mass and rate of the acceleration. So inside this acceleration force we have two forces. One is the linear acceleration forces and another one is the angular acceleration forces. So these two related concepts that describe the motion of an object. So we know. So linear acceleration force, that is a force required to accelerate an object in a straight line. So it is defined as the rate of change of the object's velocity with respect to the time. So what is the unit of this linear acceleration force? We know that is a force, that means Newton. So next one is the angular acceleration force. On the other hand, it describes this angular acceleration force. It describes the rate at which an object rotates or change its angular velocity. So it is measured in radian per second. That means radian per second square. So these are all the forces that act on the electric vehicles. Do you have any doubt on this? So what is the forces act on the electric vehicle? Do you have any doubt? Thank you, Sanju. Thank you so much. So this is all about today's session. Do you have any doubt? If you really like the session, give the heart in the comment box now. Do you have any doubts? Do you have any other doubts? You can ask in the live chat now. I will answer you. Yeah, Pratik. So regenerative braking system in electric vehicle means this regenerative braking that exactly capture the kinetic energy produced during the braking. So, and use it to recharge the battery. So, when the driver applies the brakes, means the electric motor works in the reverse to slow the vehicle down. So, and generate the some electricity. So, which is then fed back into the battery. So, this is called regenerative braking system. And thank you, Nani. Thank you. Do you have any other queries or doubts? Thank you so much, Pratik. Thank you, Priya. If you really like the session, thank you, Priya. Thank you. So this is all about today's session. So first we will saw about EV trends and global trends and recent regional trends, and then EV charging and job opportunities that are available in the electric vehicle industry. Thank you so much. Thank you, Ritu. Thank you, Convert. Thank you. Thank you all. So if you have any queries or doubt, you can ask in the live chat. Thank you, Habibullah. Thank you so much. Thank you all. So what salary? Okay. So if you are a fresher means I think 2 to 3 lakhs per year. Yeah, thank you. Thank you all. Yeah, absolutely that affects the battery's life. That's why we will choose efficient batteries for electric vehicle. Lithium ion batteries and nickel cadmium batteries like that. Okay. Thank you all. Thank you so much. Thank you for this active participation throughout this entire session today. Thank you all. Thank you, Nani. Thank you, Pratik. Yeah, we will share the attendance link. Thank you, Pratik. Thank you. I hope you continue this electric vehicle design topic. Yeah, thank you. Thank you, Pratik. I hope that you found this session will be very valuable and also the engaging. So thank you all. Thank you, Jeevaratnam. Thank you. Thank you so much for your active participation throughout this entire class. Thank you all. Thank you, thank you, Shakshi. Thank you. Thank you so much.